The transparency of water and the opacity of ice are due to the fact that water molecules are spaced apart enough to allow us to see through them. The molecules of all substances are separate from one another, and each substance itself is composed of distinct atoms. The atom consists of protons and electrons, which are themselves separate and spaced apart in a manner comparable to the distance between the Sun and its planets in relation to their sizes. All solid materials are essentially a vacuum interspersed with atoms, and what prevents us from seeing through objects is the fact that X-rays penetrate these microscopic distances. However, our limited sensory tools and the light waves we use to see reflect off the surfaces of objects, thus preventing us from seeing through them. Beyond the 7 colors of the visible spectrum, there are shorter waves, such as ultraviolet, and longer ones, such as infrared. These waves, though they exist, are invisible to us and beyond the perception of our eyes. However, we can detect them using sensitive photographic plates and thermometers. Hence, all the colors we perceive in objects are merely symbolic representations of different stimuli, processed by our nervous system through its limited sensory mechanisms. Similarly, the taste, smell, texture, hardness, softness, and geometric shape of things are simply the ways in which we are affected by them. They are subjective images that do not exist outside the scope of our senses. There is a gap between us and the external world that prevents us from perceiving it as it truly is. We are prisoners of our limited senses and our incapable nature, which transmits to us a distorted, incomplete, and fragmented image of things, with some objects remaining completely unseen despite their existence. This is the extent of our uncertainty. Einstein, with his theory of relativity, attempted to abstract this uncertain reality into mathematical equations, using calculations and numbers to offer glimpses of the true and actual reality of things and the world beyond our limited senses and nature. In 1929, Einstein announced the unified field theory, believing that the universe is a harmonious unit governed by a single simple law that the human mind can discover and comprehend. However, he later rejected this idea or theory and resumed his search. The maximum speed of motion is the speed of light, 186,283 miles per second, and this number represents the limit of our knowledge, beyond which our calculations and mathematics cannot proceed. Light, with its constant speed at the farthest reaches of the universe, unifies scattered phenomena under one set of laws. Can it, however, connect all moving groups and transfer between them without change? This is the foundation upon which Einstein built his concept of the unity of natural laws, believing that the universe is simple and that its many diverse phenomena are governed by a coordinated unity. Newton similarly sought to understand true motion in the universe by proposing a theory of relativity, but he later admitted his inability to prove it. Einstein's first theory of relativity declared that the laws of the universe are the same for all bodies moving uniformly and are constant relative to the sun, the moon, stars, meteors, and comets, all of which move uniformly within a single system. Time, too, is a variable quantity, dependent on the moving group from which it is derived. Every time reference has its origin in the motion of a body and the movement of the group from which it is drawn. Thus, time is meaningless unless it is related to the system from which it is derived. If the motion of a body changes, its time must also change accordingly. In this way, Einstein was able to demonstrate the inadequacy of Newton's mathematics in calculating the speed and large dimensions of the vast universe. Einstein rejected the idea of absolute space, determining that space is always a variable and relative concept, measured in relation to another nearby variable. He also admitted his inability to discover the true state of an object in terms of motion and rest, as there is no absolute state, only relative connections. Similarly, Einstein proved that mass, like time and space, is relative. After it was believed to be a constant quantity unaffected by the motion or stillness of a body, Einstein demonstrated that mass is a variable quantity influenced by the motion of a body. The faster a body moves, the greater its mass. As a body approaches the speed of light, its mass becomes infinite. Einstein was able to establish the precise equation that shows the relationship between a body's mass and its motion. A body gains mass as it gains motion, and since motion is a form of energy, energy can be converted into mass and vice versa. A body that gains energy simultaneously gains mass. It was not long before concrete experiments emerged to prove the validity of this equation, moving it from the realm of hypothesis into that of established facts. Experiments demonstrated that radioactive particles emitted by radium and uranium, infinitesimally small material particles, travel at speeds close to the speed of light, and their mass increases in accordance with Einstein's calculations. This equation paved the way for the creation of the atomic bomb, marking the beginning of a profound opening in the world of energy and the invention of new forms of atomic fuel. The theoretical result of this historical equation was the complete collapse of the barrier between matter and energy. Inert matter contains motion, and there is no distinction between sound, light, heat, magnetic motion, and electricity. Inert matter, which was shown to possess inherent motion, was revealed by Einstein to be a mere illusion of the senses. He dismantled the illusory barrier between matter and energy, revealing the secret of mass, which contains within it a form of light called motion. After Einstein broke down the universe into its fundamental components, space, time, mass, and field, he negated all absolutes and demonstrated the impossibility of distinguishing between motion and stillness, as established in his second theory, known as general relativity. He faced the great challenge of explaining and revealing the overall shape of the universe. Is it finite and limited, or infinite and boundless as Newton believed? Is it flat like a sea in which stars swim, or deep like a well in which stars hang in its depths? Thanks to the theory of relativity, it became possible to calculate the average density of matter in an unlimited universe. The theory states that every body existing in space and time creates a field around it, causing the space surrounding this body to curve. Based on the equations of relativity, the degree of curvature in space and its general field shape could be determined. By this calculation, the radius of the universe is 35 billion light-years. All observations confirm that the universe is expanding, and the stars, planets, and suns within it are moving apart at tremendous speeds in all directions. Space is inflating like a balloon, causing the material within it to become increasingly rarefied over time. Some stars extinguish and their material disintegrates into radiation, but new stars are born, and the cycle of the universe's rebirth repeats. This leads to the theory that the universe expands and cools, then contracts and heats up, and life reemerges anew. The cosmic sphere contracts, expands, and pulsates like a heart, repeating its cycles of rebirth and extinction for eternity, continuing the eternal cycle. However, Einstein realized that science is incapable of seeing the beginning and end, and is unable to comprehend the essence of anything. Science knows that photons are packets of energy, and that light rays are electromagnetic waves. It understands their motion through the ether, but it cannot comprehend the true nature of anything or how they exist in the universe. For example, the electron defies observation and analysis. When a photon, which is a packet of energy, strikes an electron, the electron changes its speed and position, making it impossible to accurately record its nature. The act of observation itself alters the nature of the electron. Thus, the laws of relativity break down when applied to the atomic realm and cannot be universally applied to the entire cosmos, as this contradicts its comprehensiveness. As a result, the edifice of materialistic theory crumbled in the face of relativity theory. The scientists and scholars of materialism saw the structure they had built collapse into nothingness. Yet Einstein did not delve into the questions of beginnings and ends, nor did he attempt to answer such inquiries in his theory. He stated that our senses cannot grasp these matters, but he believed in the harmony of existence as part of a unified whole. Einstein saw that the small atomic world is a reflection of the larger cosmic world, unified in a single system of natural laws. Moreover, Einstein did not engage in theological issues as other scientists did, often with speculation and distortion. Instead, he acknowledged the existence of a governing force behind the universe, controlling its affairs. We can enumerate the knowledge that science has achieved, but we cannot count what we do not know. It is necessary to acknowledge the limitations of our senses and the limitations of our understanding of what lies beyond nature, as Einstein advised, rather than insisting that randomness and nature are responsible for cosmic and biological evolution. We should refrain from this form of conjecture, scientific metaphysics, and speculation. It is more prudent to admit that no intellectual structure can claim to have provided the final word. Every scientific thought still lacks much before it can make such a claim, as no theory has yet established fixed and comprehensive principles for the construction of the universe and its evolution.